Statistics is the science of collecting, organizing, analyzing, presenting, and interpreting data so that we can make informed decisions. It turns raw observations into useful information. Statistics is used in healthcare, business, engineering, government, science, and everyday life. Descriptive statistics summarizes data using tables, graphs, averages, and measures of variability. Inferential statistics uses information from a sample to estimate, test, or predict something about a larger population. A population is the complete group we want to understand. A sample is a smaller subset selected from that population for actual observation. A parameter describes the population and is usually unknown. A statistic is calculated from the sample and is used to estimate that parameter. Categorical data records labels or groups. Nominal categories have no natural order, while ordinal categories have a meaningful order. Numerical data records quantities. Discrete values are counts, while continuous values are measurements that can take any value within an interval. Good statistics begins before any calculation. First, define a precise research question and identify the population and variables. Next, choose whether the study needs new primary data or existing secondary data. Then design the sample and measurement instrument. Finally, collect and document the observations. Then check accuracy, completeness, privacy, consent, and possible bias. Primary data is collected directly by the researcher for the present purpose. It closely matches the question, but collecting it takes time, money, and planning. Secondary data already exists because another person or organization collected it. It is faster to obtain, but its definitions, quality, or coverage may not match the new study. Surveys and questionnaires ask standardized questions and can reach many people quickly. Interviews allow follow-up questions and provide detailed explanations, but require more time. Observation records behavior directly, without relying only on what people say they do. Experiments deliberately change an explanatory variable while controlling other factors. Randomized experiments provide the strongest evidence for cause and effect. Focus groups use guided discussion to explore opinions, language, and new ideas. Sensors and instruments collect objective physical measurements such as temperature, pressure, location, or heart rate. No collection method is universally best. Surveys provide breadth. Interviews provide depth. Observation captures behavior. Experiments test causality. And sensors provide repeated objective measurements. Secondary data can come from internal sources such as sales databases, financial records, production logs, customer systems, and previous company studies. External secondary sources include government census tables, open data portals, research articles, institutional reports, industry databases, and public APIs. Before using secondary data, evaluate relevance, authority, collection method, timeliness, accuracy, and permission for reuse. Probability sampling uses random selection with known probabilities. It supports statistical inference and measurable sampling error. Non-probability sampling includes convenience, purposive, quota, and snowball methods. These can be useful when access is difficult, but generalization is weaker. Suppose researchers want to know whether air pollution increases respiratory problems. They collect primary data by surveying residents, testing lung function, and installing local pollution sensors. They also collect secondary data from government pollution records, weather stations, census tables, and hospital summaries. Combining both sources provides richer evidence. But dates, geographic areas, definitions, and privacy rules must be aligned before analysis. Selection bias occurs when the sample systematically misses part of the population. Measurement bias occurs when questions or instruments consistently distort values. Non-response can also create bias when respondents differ from people who do not participate. Ethical collection requires informed consent, privacy, confidentiality, secure storage, and transparent reporting of methods and limitations. Begin with a clear question. Define the population and variables. Choose primary or secondary sources. Select an appropriate sample, and collect the data consistently and ethically. The central lesson is that reliable statistical conclusions begin with relevant, representative, accurate, and ethically collected data.